The life-giving rhythms of our planet, the tides, seasons, even the length of our days, are largely influenced by the presence of one celestial body in our solar system, the Moon. Yet the Moon might never have come to be had it not been for one extraordinary event that led to its formation more than 4.5 billion years ago. How this actually happened remains one of the greatest mysteries in planetary science, and one of the critical questions that NASA scientists set out to investigate during the Apollo lunar missions. At that time, in the late 1960s and 1970s, there were several theories about the Moon's formation: the co-formation theory, the capture theory, and the fission theory. The co-formation theory states that the Moon formed in the same way, time, and place as planet Earth, around the time our solar system was born. This is likely the same way Jupiter's moons Io, Europa, Ganymede, and Callisto formed. The capture theory holds that the Moon was captured by the Earth after forming elsewhere in the solar system. This is similar to how Mars captured its satellite asteroids, Phobos and Deimos. The fission theory suggests that our Moon was once part of Earth. Soon after its formation, Earth spun so fast that it ejected a huge chunk of molten rock into its orbit, which ultimately became the Moon. After the Apollo missions returned with their lunar rock samples, scientists realized there was a problem. The chemical composition of the Moon rocks and the physical models of the motion of the Earth and Moon do not fully support any of these theories. The lunar rocks all looked similar enough to Earth rocks to suggest that the Moon formed from the Earth. However, there was one puzzling difference. The Moon rocks were missing certain elements found in Earth rocks, like potassium and sodium. These elements are known to evaporate in extreme heat. Scientists hypothesized that the Moon must have come from the Earth, but that at some point it would have heated to a temperature hotter than Earth. None of the three theories that existed at the time accounted for that. So scientists began leaning toward another idea, called the giant impact theory. The giant impact theory proposes that the Moon formed when a Mars-sized planet struck the Earth as the Earth was forming. Scientists named this planet Theia. After the impact between Theia and the Earth, molten materials were flung into orbit around the Earth, which eventually coalesced to become the Moon. Today, this is the most widely accepted theory of Moon formation, but the details are still being debated. One trouble with the giant impact theory is that, if true, it would mean that the Moon would have been made of materials from Theia as well as the Earth. But we know that materials from the Moon and Earth are nearly identical, like identical twins with the same genetic code. One new modification of the giant impact theory helps to explain why the Moon's materials show no evidence of Theia. A planet is defined as a celestial object whose self-gravity is strong enough to give it its rounded shape, make it hotter and spin it faster, and the planet reaches a tipping point. The material at the equator spreads into a donut-shaped disk. This disk is called a synestia. A synestia is what a planet may become when heat and spin push it over the edge of a spherical shape and into a donut-shaped disk. This Earth was already deformed from another giant impact. When Theia impacted the Earth, the energy from the impact vaporized Earth's surface, its water and atmosphere, and mixed all those gases together in a matter of hours. The Moon formed inside the huge resulting synestia, caused by the violent merger of Earth and Theia. It grew from a magma rain that condensed and coalesced. Earth gradually cooled and shrank from its synestia, leaving a mass of molten debris in its orbit. This mass eventually cooled to become Earth's Moon. This latest theory of Moon formation is helping to resolve a long-standing scientific mystery. However, much still remains to be learned. Refining the details of our Moon's origin story will continue to engage astrophysicists and geologists for many years to come.